Good afternoon, everybody. Welcome to the fourth of the Cisco sponsored track sessions today. I'm going to quickly introduce our presenter. We've got actually a real treat for you today, our last session. Shannon McFarland, one of our distinguished engineers at Cisco Live Hall of Fame presenter.
That's what they say.
That's what they say, okay. We'll be talking about linking your OpenStack workloads to public clouds with SD-WAN. And Shannon, it's all yours.
Awesome. Thanks, folks, for spending time with me. I think we only have one set of sections after this, or are we at the end of the day? Is that it? Okay, that's good. Awesome. So our topic today is talking about linking OpenStack clouds, and we're not talking about OpenStack clouds as an actual public cloud space. We're actually, in our reference today, is OpenStack as private clouds, talking to other public clouds. If you have attended any of the previous OpenStack summits in other geographies, I've done a similar talk. Most of them have been focused with more legacy IPsec, dynamic multipoint VPN, those types of designs. But what we're kind of coming through on this particular talk is looking at it through a software-defined WAN lens and from an automated lens. So that's going to kind of tag along with some of the previous designs that we've talked about at this event, but we're going to be focusing on newer technologies. My name is Shannon McFarland. As Gary pointed out, I've been involved with OpenStack since the B release, and so I've been involved with mostly Neutron, but a lot of heat as well, and I do a lot of stuff in the public cloud space as well. So we're going to get busy here. So our agenda, we're going to do a level set of a lot of the common hybrid and multi-cloud design options that are out there, just so that we can kind of level set what we're moving into. We will do a quick two-slide intro on SD-WAN, or software-defined WAN, what that looks like, at least from Cisco's perspective. And then we're going to get into the bulk of the talk, which is utilizing a specific bit of functionality in the Cisco SD-WAN portfolio called Cloud On-Ramp. And we're going to use that automated framework to deploy connectivity from an on-premises private cloud that is sitting in front of OpenStack in this particular case, and then we're going to link that into a variety of different public clouds, and then we'll wrap it up and get you out of here. So just kind of a level set. When we are engaging in on-premises environment, that's pretty cool, an on-premises environment with a public cloud, we can walk through a wide variety of types of connectivity. Maybe a loose cable. I don't know, it just auto-detected. I've got it set best for, so I can do scaling. I see the occasional line, but it does seem better. Roll forward for a while, see what it does. Okay, all right, thanks, bud. So when we're looking at an on-premises private cloud environment where we've got OpenStack sitting in here in one of our data centers, we always have the option to engage in a native cloud framework from a specific provider. In this particular case, we got Google Cloud Platform, or GCP, and we can utilize a native framework that they have, such as the Google Cloud VPN. AWS has one, Azure has one, Alibaba has one, many people have one, where you can just simply go into the dashboard or an API or CLI and turn on IPsec point-to-point between the two, and then optionally, you can wrap dynamic routing into that environment through BGP. Static routing, obviously, is available as well. You also have the ability to then start adding virtual routers into this context. So we'll look at a wide variety of scenarios here where we've got our on-premises environment. It doesn't really matter what our workload is, but we're using physical or virtual routers or firewalls to stitch point-to-point IPsec connections into a virtual routing appliance, maybe something that you would have like a Cisco CSR or another product that's in an AWS marketplace. And then utilize a regular VPC routing model to connect into your workloads. One of the more popular ways of doing this, because it's more scalable, it allows you to actually stitch together a lot more VPCs together in a cleaner model than using something like VPC peering, is using what is known as a transit VPC model, which is a dedicated VPC or VNet, where you're utilizing virtual routers. That is establishing connectivity between there and your on-premises environment, and then you are establishing kind of a back-end VPN gateway connection there. And then finally, you can continue to glue these together and utilize a transit VPC plus an on VPC or VNet virtual router. So these have been around for a very long time. So if these are new to you, then you're kind of new into this space, because this has been around for quite some time. And yeah, that is getting exciting on that video. Another way of doing this, and Equinix was up here talking a couple of talks ago, is you can utilize Direct Connect, ExpressRoute, Interconnect, one of those types of features or services from a public cloud provider, and allow you to basically bring your connections from your on-premises environment directly into a colo facility like Equinix. And then from the Equinix connection, ride a direct connect or ExpressRoute type of connection directly into that environment. And you can also do that with encryption, without encryption, with offloaded services, all kinds of varieties that are out there. So again, these are just a refresher. We've had these around for a long time. These are very, very well-proven designs. Now, when we start to look at the on-premises side of this, we've got lots of multi-cloud topologies that are available to us inside of the OpenStack world. The first one is we've got OpenStack running in our environment. We leave our OpenStack environment into an on-premises data center environment, and then we leave out to some dedicated tier of our network that is either providing VPN or a direct connection into a colo facility. A second one would be is that we actually want to take, as OpenStack operators, we actually want to own the connectivity between ourselves and the public cloud themselves, and we're just simply writing the rest of the network as a transit. So something like embedding a virtual router as an actual instance inside of your OpenStack environment, and using that to provide encrypted connection out there as well. And so this has been around for quite some time as well. Then the third one is natively use something inside of OpenStack as a service, such as VPN as a service, where you're actually using a native VPN service itself to actually fire off not only your outbound connectivity into your local data center, but you're also using IPsec and IPsec rule sets inside of VPN as a service to establish that encrypted connection. We are going to be talking primarily in this discussion in here with the first option, because it is wildly the most popular way of doing things. It's just simply allowing you to use purpose-built appliances, purpose-built network operations, and purpose-built designs to allow you to not have to worry about all of the encryption, point-to-point, pre-shared keys, all of those things inside of your OpenStack environment. You're using the automation and the frameworks that live above OpenStack to get that done. And so that's really the design that we're going to walk forward through in here. So how many people here have any experience or knowledge of SD-WAN? Okay, so a few folks here. So we're going to take a quick view of what software-defined WAN looks like, at least from Cisco's perspective, but pretty much everyone out there in that space kind of operates in the same type of overlaying architecture. So when you look at the Cisco SD-WAN, this is a Cisco-sponsored talk, so we're focused on the Cisco view of the world here. But if you look at the Cisco SD-WAN architecture, we have a variety of two planes. We have a kind of a broader control plane environment, and then we've got the data plane environment. So if we take a look at the control plane environment here, we've got three primary bits of componentry that we have in the environment. The first one here is the orchestration plane, and this component is known as VBON, and this is the device or the component that is the first point of contact for authentication. So when we do zero-touch provisioning of a brand new device in the cloud or on premises, it knows to go and automatically register itself with the SD-WAN environment. And the automation and the programmability of that device knows, go call home, this is your home. Once I get there, we have pre-authorized that device to be a part of our software-defined WAN environment. And so the first point of contact for that and the orchestration of that is the VBON component. And it can be a physical or virtual footprint. The next one is the control plane. So vSmart is out there to do fabric discovery. It's out there to detect where everything's at, where all of your sites are, how do I deal with routing policy, encryption policy, actual security policy. Those types of things are controlled by vSmart. And then finally, the thing that you interact with the most is the management plane, and this is known as vManage. This is the actual UI or the CLI or the API interface into your WAN environment. And this is where all of our policies and templates and so forth exist. So that does it for the control plane, pretty much. And then the data plane are the actual routers themselves. We call those V-edges if you are under the original Viptela footprint of that operating system. And then the newer footprint is referred to as the C-edge because it's an iOS XE native environment. So that's the two devices that we're going to talk about quite a bit in here. So what we can do is we can talk about this in the easy way or the hard way. I always prefer the hard way because doing things the hard way the first time educates you on the componentry and the design that you need later on when things go wrong. So from a high-level perspective of what you would do in stitching your OpenStack environment into a public cloud with SD-WAN is first you would design it. You would go and deploy those 3 control planes that we talked about before. You would deploy your on-premises data plane, those V-edges and C-edges, and that would also build the connectivity into your OpenStack environment. You'd create and gather your public cloud credentials or your IAM roles. We'll talk about that in a couple of slides. And then the bulk of our talk is going to be focused around item 5 and item 6, and that is where you're going to go and use the automation that we have inside of the SD-WAN portfolio to build 2 sides of this conversation. The first one is the transit VNets or VPCs themselves, and then we're going to map the VNets or VPCs on our public cloud to that transit. And this is 100% automated. I'm going to explain it to you in a horrible, nasty, really atrocious way so that you walk out of here understanding what the automation is actually doing for you. Because the automation itself is click, click, bang, and you're done. But when you really want to understand what the routing and the encryption topology looks like, that's my job is to kind of educate you on what's going on behind the covers. Then finally, once this is all operating as an actual hybrid or multi-cloud environment, then you would go through and deploy your policies that meet your specific topographic requirements. Like you want a hub and spoke model, you want a full mesh model, maybe you want part of your connections on the public internet, part of your backhaul connections on MPLS. And so all of those things would come through in the policies, and then once you're done with that, obviously you want to have a nice day. So let's start with this process of how does this thing work and how do we actually get it built. So the Cisco SD-WAN cloud on-ramp solution today fully automates Azure environments and AWS environments, and GCP environments is coming in a few months. So we're going to focus in here on Azure because it operates the exact same way in AWS. I do have some AWS content at the end, but they basically operate in an identical way, as will GCP when it's available. So what you would do starting off is that you would do your design, you would go out and deploy your control plane in SD-WAN, maybe it's already out there because it's running your branch environment, and then you would finally decide, okay, we're going to spin this thing up. We've got resources and logins and so forth out in our public cloud, and we're going to go and turn this thing on. So literally the 4 screenshots that you see here is it. The first thing that you will do is this side, these 2 screens here, is building the transit VPC environment for you. So you would log into the vManage console, you'd pick which cloud that you're using, you would gather your login and credential information, it tells you how to do that. The next thing you would do is click login, it would log in and then understand what resources you have for the account you're using. The next thing you would do is you would choose what region that you would want to operate in. You would create a name for your transit environment, pick which vEdge or cEdge image you want, the size of that image, and then 2 of these vEdge devices that are going to be operating as your data plane in the cloud. So once you kick that thing off, it'll actually go out, log in, and do all of your creation of resources based upon the account or role that you gave it. And this is it. It's completely hands-off from this point. The only option that you have is you can click on this advanced link here, and you can dictate what your actual IPv4 CIDR is inside the VPC, but as we'll see, it doesn't really matter that much. Its default is a 10.0.0/16, but you can make that whatever you want just so it's non-routable. Once that's built, then you are going to create the second half of your connection, and this is referred to as mapping. So what we're doing is we're building a transit environment, and we're just letting it sit there. And then someone, such as an application team that wants to build containers or virtual machines or a registry, will come and say, we need to establish connectivity between our public cloud and the hybrid cloud. Can you help us? And typically what happens operationally in an enterprise environment is this comes into another team as a request, a ticket if you will, and they will say, we've got 2 VPCs that are currently running Kubernetes or they're running EC2 instances, and we want them to have connectivity into the enterprise space. You would then either obtain credentials from them or a role from them so that you have access into their VPC account information, or you are the account holder yourself and then you have full authority to get into there. And once you enter those credentials, you would then come in here and you would select your account type. This is an Azure account type here. And then it would discover all of the VNets or VPCs that account owns. You pick which one that you want to build into your hybrid cloud environment. And the very next thing that it does is start asking you, what do you want your IPsec IP addressing to be? What do you want your BGP information to be? And you click map VNets and then you go drink. And like 10 minutes later, you come back and now magically that VNet or VPC has encrypted dynamic routing connectivity to the transit, and that transit has dynamic routing and encrypted connectivity back into your on-premises environment, okay? So this is the flow of what you would do graphically. That's as easy as it is. Literally 4 screens for you to get this entire thing built. Now I'm going to hurt you badly by explaining to you the horrible way that this actually works under the covers, so prepare yourself. So again, most of what we're looking at here for Azure applies to AWS. So again, we've got our OpenStack cloud environment over here. We've got our vEdges and cEdges and our control plane pre-built. Again, this is probably already in your environment if you're an SD-WAN customer. The very first screen that we looked at builds this. It builds 2 vEdges inside of a VNet in this particular case. It stitches together dynamically all of this IP addressing for you. You don't have any interaction with that outside of identifying what the CIDRs are. And then you're done. So if you have already built your SD-WAN on the on-premises side, then this connectivity is established by default. So you have encrypted dynamic routing connectivity between this gateway and your on-premises environment. So then you're done. You sit there and wait for someone to say, we've got a VPC or a VNet that we want to stitch into this environment. So once they come around and ask you for that, then they will have a VNet or a VPC. They could be you, but this also could be an application team. And they would have basically an existing workload or existing VNet or VPC with some subnets in there. And you would go back into the vManage console and do the second half. You would map this to this. Now here's where it hurts. This is what happens. So I will let you look at these slides and replay this talk over and over again so you can go to sleep quickly. But what's basically happening in the background, and again, we're not going to walk through all of the IP addressing of this, but what happens in the background are 2 things. They're the same 2 things that happen if you built this on your own with a native cloud framework. It's doing IPsec and it's doing BGP. That's all that ever happens between you and a native IPsec environment with a public cloud provider. The only thing that we're doing here is automating all of that and building it in a highly available manner. So what's happening here is that we are creating redundant IPsec connections. We are creating redundant BGP connections. We're stitching all of this together so that if there's ever an IPsec or a BGP failure between these environments, we've always got another half to go with it. This takes care of assigning all of the publicly routable IP addresses, linking all of the BGP ASs that you identified, and away you go. And basically what then ends up with is linking all of your public cloud containers or workloads, whatever you have, will traverse this network through the VPN, through the transit, and right back into your head-end. And we'll kind of walk through how we know this is true. So if we take a look at this, and again, the two things that you need to walk away from is all this is doing is automating IPsec and automating dynamic routing. So what's happening in this environment is if we take a look at the V-edges that are actually built for you out here, you will take a look at the IPsec interfaces that are there, and you will take a look at what the tunnel source and tunnel destination is that are programmed into this environment, and you will see that they map up with tunnel source being one of your transport VPNs in the gateway environment, and tunnel destination is one of the CGW or customer gateway connections that exist at the public cloud. So you've got IPsec times 4. Again, we do this 2 connections with 2 redundant links per one of these. The next thing you'll look at is dynamic routing. So we can see on our router that we have BGP AS information, we've got the neighborship created, and we've got the remote AS between these 2 connections built. So what happens there is once you get into your Azure or AWS environment, you can actually take a look at what the virtual network gateway is advertising to your SD-WAN. In this particular case, we're actually running an Azure command that states that we're advertising the 1016 space, which is actually what's running inside our workload here. And we can see in the transit that we actually see that route via BGP, okay? So if you are a networking person, this is as boring as hell, right? It's just IPsec and it's just BGP. It's what we've been doing forever. But if you're also a networking person who has built these connections by hand, you know how bad they suck, right? A lot of stuff can go wrong, especially when you're dealing with overlapping CIDRs between transit VPCs, and how you actually build all of the key structure to match what the public cloud provider is building for you. We take all of that away and just build it through 100% of automation. So once we've got IPsec and we've got dynamic routing built to the public cloud, the next half is making sure that what we wanted to happen in our on-premises environment where OpenStack exists is also functional. So if we take a look at, again, one of our transit devices and we look at our IPsec relationship, we can see that we've got a connection from our VPN into this single V-edge device. So we've got encrypted connectivity going there. And we can see from this device, he's got redundant connectivity to these 2 through its outbound connections. Now, let's glue all of this together. Let's make sure that we know that we've got connectivity from one end of our environment, the OpenStack side, all the way through the gateway and into the public cloud side. So again, if we go up to the transit device, we're just looking at one of these, we can see that the OpenStack prefix, 10110/24, we have learned through what we have as a really sweet routing and policy component called the Overlay Management Protocol. It's basically like high availability, quality of service, policy, and routing all wrapped into one protocol. And we can see that the transit is dynamically learning all of the on-premises side from the OpenStack environment. And we can see that we obviously have all of the 1016 space learned through BGP on that connection. On the far end of this environment, we can see that our V-edge on a show IP route, 1011 is behind us, 1016 we've learned over the cloud, and away we go. So when we glue all of these things together, one, we've got end-to-end connectivity, and we can verify that connectivity. So if we're in an OpenStack environment, we can ping one of our resources in the Azure public cloud, and if you've got your security groups all figured out, you will get a ping to that. You can connect to the workload, and if you go out, for example, to your resource that exists out in the public cloud environment, you can see that you're actually truly connected on a non-NATed, fully routable private address space. So again, this is painful to look at, but what happens when something goes wrong in this, or someone from the network operations team says, that's cool out of the box, but now we want to stitch you into our WAN. So that branch offices have connectivity into these workloads just like the on-premises does. So you need to understand the flow of what the automation is doing. It's great to know Ansible or Terraform or whatever your automation scheme is, but if you don't understand the order of operation and you don't understand what the resource consumption is of that automation, you're going to be in trouble when something happens. So when we look at the end-to-end connectivity of this environment, we can see that from our virtual machine, our next hop is, in this particular case, it's just a back-to-back connection that our vEdge is our first hop. We ride across our IPsec and BGP connection into this particular router, 254.1 is the next hop. We ride into the VPN gateway, 168.61 is the next hop, and then we end up in our VNet environment there. So yes, a lot of talking, a lot of pointing, and a lot of addresses. But this has happened in 4 screens and in roughly 10 minutes. So this is a very, very nice way of being able to take care of the challenges of dealing with the automation of the actual transport side. Now, once you have this particular environment running, you can then rinse and repeat this on multiple different cloud providers and on multiple different VPCs for multiple different workloads. So if you take a look at this from an AWS perspective, it looks pretty much the same thing. It's building a gateway VPC, it's building a host VPC environment, and it's creating a mapping of those in a redundant fashion. So once you have all those things together, you now create a multi-cloud. So hybrid cloud being 2 clouds linked together, multi-cloud, we're linking more than 2 together. So let's link them together. In this particular scenario, we've got our Azure connection that we built before, we've got our AWS connection that we looked at, and we've got our OpenStack connection on premises. And we have stitched this entire thing together 100% through automation. And when we look at this from a routing perspective, this is the default that comes out of the box. Now, what becomes super powerful with an SD-WAN from pretty much any vendor is the beauty of the SD part. That software-defined insinuates programmability, automation, and most importantly, policy control. So out of the box, without me doing anything, I had complete unobstructed dynamic routing between the Azure environment. I can see the on-premises, I can see my own stuff, and I can see the AWS workloads. And the AWS side, I can see the on-premises, the Azure, and my own stuff. And on-premises, I can see, again, all 3. This is out of the box. But what's powerful when you're looking at software-defined WAN policies is what if you say, okay, well, I actually want to create a structure in which things come into AWS on a front-end load balancer. And then they are going into some sort of a Lambda call, and that Lambda call is then triggering some behavior that actually needs to happen inside of Azure's environment. Well, you can create policy that is point, click, push in this environment that locks down the traffic flow so it maps to that behavior. So when you've got an application framework that requires traffic flow, instead of you logging into 10 different devices at 4 different locations, you're simply building this policy and then deploying it to those sites through point, click, and you're done. So again, very quick and very easy to use out of the box, but it's also very powerful once you're into the policy framework. So as we kind of wrap up here, a couple of the things that you need to walk away kind of understanding. Automation is awesome. Automation out of the box is awesome, but also automation out of the box basically dictates a prescriptive way that you do things. And so some of the stuff that you need to kind of understand when you're using the cloud on-ramp solution is that out of the box, before we deploy cloud on-ramp, this is what, for example, in an Azure environment, when you actually look at a network interface that at an instance exists, this is a default route table that all Azure instances operate, and their default goes out to the internet. When you deploy a cloud on-ramp solution, it reprograms all of that. And it basically says if you're going to go to an all routes 0, which would typically go to the internet, it's actually pushing you into a transit. Well, this immediately breaks everything if you've already got workloads that want to go to the internet. So think that you've got a container in Azure, and that container is pulling from the now broken hub.docker.com. And it went through the internet to get there. The second you as a network operations person or whoever's responsible for this deploys this, that is gone until you implement a policy that allows that routing to either go back to the internet or it goes back to the enterprise to go to the internet, whatever the case might be. But you need to kind of understand that out of the box for the enterprise InfoSec requirements, it does change the routing out of the box. So one way that people get around this very quickly in these hybrid cloud environments is that they will go through, and I'm not going to walk through all of this, but basically they will do what's known as an internet exit routing policy. And that will say, if you are a container and you're trying to go out to the internet for a specific destination, just simply continue flowing through your default route, but we will then just pop you to the internet directly through us instead of you going all the way to the enterprise. Now, if you do this and you do it without your enterprise InfoSec team knowing about it, someone will come to murder you. Right, so you need to get this approval because this typically creates what is known as a split tunnel, and this very much it creates a violation of what you're trying to get done inside of an InfoSec policy. But these are the types of things that you kind of got to work through in these solutions. Okay, so what we've kind of looked at is that, one, you can very rapidly deploy what used to be extremely painful to do. The automation is great. You can call APIs. You can do this stuff very quickly and very rapidly. And once you get that up and running, you now have a very powerful baseline. You're probably not going to be done once this is finished. You're probably going to have to operate on some policies. But once it's done, you now have the ability to stitch by policy all of these public cloud environments, all of your branches, all of your data centers where OpenStack might exist, or even out to a public internet where another, for example, rack space is sitting. You can stitch all of these things together, and once the transport has been taken care of for you, the rest, all you have to worry about is what policies allow traffic to flow in which directions. So lots of reference material for you to take on how you go and actually get the V-edges, how do you deploy the control plane, and how you deploy the cloud on-ramp solution. So from a summary perspective, there are a lot of options for you. Again, you can use native cloud frameworks, VPN, BGP, and off you go, but that also starts to run out of horsepower. The more connections you build, the more you create mesh, the more you create high availability requirements that are probably beyond what you want to live with. You also can run into a situation where when you do these with separation of control, where someone owns the OpenStack environment and someone else owns the network operations side that actually connects to the public cloud, those two teams have to agree on something. And routing and encryption and those types of things have to be a part of that conversation. And so there's a lot of designs out there that we've talked to over several years at the OpenStack and Open Infrastructure events to be able to do that. And that's kind of what that first section is dealing with. SD-WAN greatly simplifies that for you. Instead of having to operate with manually deploying resources and manually upgrading software, manually activating licenses, and then manually creating encryption and routing, it provides a lot of ease of taking care of the most laborious part of this, and that is simply stitching together the actual WAN itself. So that's it for me, and I will take questions.
Thank you, Shannon. I hope you're all taking notes because there will be a quiz now. No notes. Okay. Questions? I can bring the mic to you. We've got a mic right there. Here, we'll make it easy.
So does this SD-WAN works in mesh mode or hub-spoke mode?
Yes to both. So it literally is a policy change, and you can do hub and spoke in the same devices to different sites, and then from those same devices you can choose that they would be in mesh in a different part of the WAN. For example, if you've got an MPLS environment, you can do full mesh in that between those connections, but if you've got internet connectivity out of those same devices, you can do hub and spoke. So it's both simultaneously or one or the other, however you want to dictate your policy.
Okay, so it's my second question. If it's in mesh mode, if my both branches are behind NAT, are there any implications or restrictions which we need to follow, or any specific TUN or stun server needs to be used for that?
So if the V edges or C edges, the actual data plane components are in a branch and they are behind a NAT, the IPsec, IKE, routing stuff all works because it supports, by RFC NAT transparency. So that part of it works. The only challenge that you may have is when the devices are initially registering with vBond, it's generally not the devices themselves that have a challenge, it's vBond. If vBond has been put in an environment where it's behind address translation, then things can get a little dicey and you need to manually basically kind of intervene and making sure that those devices can properly register with vBond. But once the actual control and data plane connections are up, again, which is IKE and IPsec, you should have no problem because they're all supporting NAT transparency.
Okay, yeah, thank you.
Mm-hmm.
Any other questions for Sean?
Everyone just wants out, Gary, and they want to drink.
Well, no, all I know is it allows me to buy dog food from Amazon at about 2 a.m. So thank you all for coming. If there are no other questions, that didn't work very well at all. And if you have any other questions or want to see any of the other Cisco stuff, we have our booth down in the marketplace. And thank you all for coming.
Thanks. Have a good day.